In this video, I'm going to need to clarify a few things. Let me res this rock. And another rock I'm going to res. When I'm talking about physics optimization, physics shape optimization, like this rock here, and I get my features, and and my physics shape type and material type is set to stone. Under this particular object is, the gravity, friction, whatever. If you look at the outline shape, there's a different physics shape than the one you might expect. And this doesn't actually show you the physics shape, just parts of it. Now, when they create a rock, I can, they make a general physics shape, I can walk up on it. But if you notice, I'm walking on the edge here, my feet are inside. So, of course, a scripted object like a ball or a baby or an NPC, non-player character, can go right through it. And they'll fall into it and then go into the side and then roll out. But you can walk up on it and it's fine. But the ball may bounce off the top, or it may fall through or go straight through it, depending on where it hits and the velocity and all that. Now the rock, say this example rock. Here I am, I'm going around a rock. But that's because I've already done something. I put a prim around the rock. Let me lighten it up a little bit and unlink it. So here we go. I can walk right through this rock because the physics shape, the baked in physics shape. Now, when creators upload custom physics with models with their mesh objects, and those models dictate how the object interacts with other items and avatars in the world. If the creator has a specific physics model, it can limit your ability to modify that object's behavior. And of course, convex hull versus prim, that can be an issue too, because convex hull, even though it's more simplified, can cause things to pass right through it. Switching to prim physics shape might help, but this option isn't always available. And of course, if you get scripted overrides in an object you embedded that enforce specific physics behavior, you can't do much with that either. And if the physics shape that was uploaded and baked in isn't thick enough, the ball can, let's say a golf ball can go straight through it. Now look at this nice rock here. Boom, I can walk right through it on this side because it has a very basic physics shape that doesn't match anything like the rock. Now this side is better, not perfect, but see? But then I can go right through it. No matter what I set that as, stone, plastic, flesh, or whatever, that baked-in physics model overrides whatever my settings are in there. Now, whatever you set, when we set these things up, this is generally for a prim, and it could, on certain mesh objects, allow you to define things. But the prim like this, a basic box prim, not mesh, That's what that setting's really for. Now I'm going to do a test here. I'm going to take this particular rock. I'm going to drag it over, drag copy. Adjust it. Right. Back it up a little bit. Now, I'm going to copy the size, go to my prem, and paste the size of the rock. And then I'm going to go take the rock's position and paste that into the prem's rock position. And now it covers the rock. Now, it's not 100% because, remember, this rock, my rock here, has two parts, two linked parts. So if I select this and this, it's really the root prem that's the size, not the secondary prem. And I don't really need that rock there if I'm going to be doing this kind of thing, but I'll deal with that later. Let's go ahead and do this. I select my bottom link object, select my box, and link them. And now my box is the root prem. It was the second thing I selected. Now I go back and I select my name of my rock object, go back to the box, which is named object, and paste it. But I'm also going to add and put in this to let me know that it's a physical box. This product, this rock platform, and physics. And I'm not, I'm really not doing too good today. So, there I am. Now I'm going to put this down on the ground. I'm going to move it to forward here, back over here. Now I'm going to select my box. Now each one of these rocks, normal rocks, are two prems, and I'm still down to two prems with my rock one. It doesn't happen all the time, but it does on this one. Now I'm selected, and I'm going to my edit link, my first prem, my prem, and I'm going to set that to stone. My outside box. I'm going to my next link, which is the bottom of the rock. There. The underside. I'm going to set the physics shape to none. It doesn't need one. And go to the top side and set the physics shape to none. Now I'll go back to my root prem, and I'm going to take my texture. I'm going to make it completely invisible. Now, we get that down, keep that down to one prem, but usually I'm adding a prem. Now, the underside prem, I don't absolutely need that. It's going to be buried all the time. So I'm going to do something else with this. My LI is at 2, which is one more than my normal rock was. But they're not interacting with each other. The rock inside has no physics shape. Even with that physics shape, it's not going to override at my box. It's not going to interfere with the main outside box, the root trim. The really only difference here is this shape, I can walk on top of it, walk straight up it like this. But with the box around it, I can't walk up it. I can hop up it, but I can't walk up it. And it's still putting me a little bit above. And I could drop it down a little bit lower, but I don't want to. But I could walk over to my other rocks and it won't be a problem. So it's a block. So for my, let's say for my golf ball, it's going to hit it. It's going to bounce off that outside, or if my baby's wandering around, the NPC, it's going to interact with the outside box, and it doesn't matter what's on the inside. And now let's do this with a golf ball. Oh, bounces right off in the sand. I'm going to try something else here too. I'm going to go with my pitching wedge, my wedge. I want to hit it up and over and on top. And it bounces off the top and bounces off. Doesn't go through the rock, fall into the rock. It went straight off of it. See? That little path. Now, if I needed clear obstacles, I don't need people wandering up on top of things like this. Not in an obstacle course or in a position like this where I need blocking. This isn't, people are not going to be out here wandering around having picnics. I mean, they could, but, you know. So when you got something like this, you're still going to run into the physics that are predefined with the mesh object. Now, side benefit is a side benefit of this to me is that this object still has a script in it that links it to other objects, other rocks of the same nature. I still have the script inside, but I don't have the touch on that box. Now, this one, if I change this one, this who's not linked, it's going to link it. It's going to change it to that. And I don't have that touch on that box. That's the only difference is that on the box one I don't have that touch. But on the other ones, I do. And I can say rock type. And they updated them all. Even the rock with the prim inside of it. I mean, the prim on the outside of it. So I'm not losing anything on this deal. And if the other thing, look at the bottom. And I'll change it back to a rock. It doesn't really change the bottom rock that much. And we really don't need the bottom rock. Where I bottom face. Now there's only one more LI, but I was going to put that on there anyway as a blocking prim. I was going to use one LI. Now sometimes I don't need the underside, but let me show you what happens if on these particular rocks, if I go to my there, I link that, and I unlink it, and go bring it up. See, I don't need that. I don't need it. I delete it. Now look at my rock. I'm back down to one LI. I didn't need that underside because no one's going to see that underside. One prim for the one without a bounding or a box, a prim box on the outside, and one for that. And I still have the script inside. I can update it by using another rock. It's pretty nice. So I've managed to save, add an element, a blocking element to this design, and also not increase my LI. I've actually back down to where I was. So I can walk up on these, and I can walk on top of the one with the box on top of it. But I can't walk directly on that particular box without hopping. And that's fine. Not every object will need this. It's only the ones I need to block a golf ball or a baby or a bullet or a rocket ship or whatever the hell. Heck, sorry. Let's try this. Boom. Right off. Right on the edge. And that's how I get around that issue. So whatever is inherent to the mesh object that was uploaded, that predefined physics model, that can override everything. This is the rock I copied the other rock from. So I'm going to go ahead and I'm going to replace that. I'm going to take my rotation, change it to the one with the box brim on it. I'm going to copy the position, delete it. That's where I copied that rock from, and now I can just paste it, and now it's in place right there. I can't walk up it until I get around it, but that's fine on a golf course or an obstacle course or whatever. And then we're back down to one eye land impact, which is a big bonus. I'm going to do some more tests here. I'll show you. The other rocks do not have the prim back on them. So I'm going to show you how this handles this. I buried it in the ground. Boom, bam. It's knocked off. That went right past it to the one without it, and it went right through the rock. No prim bound, no prim on the outside. It went right through the rock and then down the hill. Right through it. Came right to the side of it. Didn't hit at the top. Didn't go through the top. Didn't fall through it, thankfully. But they could have fallen all the way through it. So, I'm going to go ahead and replace some of these rocks with the one with the box on it. Boundary boxes, I call it, or a blocking box. I'm going to make a few copies of those. I'm taking the one on top here, and I'm going to copy, and the rotation seems to be the same. I'm going to go ahead, copy the position, delete it, and paste one of the rocks. Do the same for the one underneath of it. Delete it, paste it on the bottom. And I blocked that in nicely. I can't walk up it anymore, but that's okay. I could walk certain parts and then walk on top. It's a bit of an artistic thing you can do here, but now we've got all these three boxes that are that maybe overlapping or not, but they're not going to allow the ball to fall into the rock or pass through the rock. Let's hit us another one. Boom. And it knocked it off in this over here now. On the left. Got rid of that. Now here are the double ones where I doubled it up. That one and this one. Now let's try this. Got to get back to where we were when up down by the sand trap. That bounced off fine. Now I'm going to hit it the other way. And I'm no higher in my lie. I'm really happy about that. The only thing I'm really losing here is the ability for people to walk up the side of the rock, whatever. But they, playing a game, I wasn't able to do that anyway, really. And so some rocks you could leave alone, but let me try that again to get to the, now that I have all the blockings in it, let's try this again. Boom. Perfect. It got up on the upper rock. It didn't sink down into the rock. It didn't go through the rock. It bounced off the top of the rock and then down and kept on rolling. And that's exactly I thought it would do. So then it didn't get caught in the rock. It didn't get caught through part of the rock. It didn't get stuck under the rock or under a part of the rock on the lip of the rock. It bounced all the way off the rock, or it got away from it. Because of the outside prim, which is called the root prim physics influence. Because the root prim generally dictates the physics behavior for the entire link set. So if you have a mesh object, if the mesh object remains linked, even if its physics is set to none, its custom physics model might still interfere, as the physics engine treats the linked object as a unified entity. Now you could use a dummy root prim, and that could help you by making, in regard to collisions. But this way I showed you here is the easiest way to do it. To keep your blocks in where you need them to be, and not have to do everything. Like if somebody's out there on a picnic or something, you don't need blocking, because they're not going to be hitting balls, hopefully, into rocks on their picnic table area. So let's try this when we're building and designing our areas. And it's a little bit of work, but once you get it down, you can define areas. But like I said, when you're talking about just setting the physics shape and the physics material shape, that really only applies to things that have a physics shape, like a prim, because, like I said, if you're encountering issues with mesh overlap, where two mesh physical objects overlap, that can become disruptive, or two physical shapes interacting, overlapping, they can cause instability, especially with mesh. And so you really have to be a trial and error with that kind of thing. And objects that are set to convex hull, which simplifies the collision detection, but can lead to issues like objects passing through or bouncing unpredictably, because also you have the object's physical model that was uploaded and baked in, and that takes priority over everything else. And so you need to, because the mesh object, physics shape to, even if I set my physics shape to none, the mesh object's baked in physics model can indeed still influence the overall behavior of a link set, because even with the rest of the link's objects inside of it, you got a mesh object with multiple parts, and you set only one part of it to none, physics shape to none. The physics model that are baked in is still influences. This happens because the physics engine in secondLife prioritizes the physics property of linked objects, especially the mesh component, regardless of its individual settings. So this little trick I showed you with putting the box on the outside, linking, completely covering the outside, and then linking it to a prem and making that prem the root prem, that becomes a root prem physics influence, and it generally dictates the physics behavior of the entire link set. If the mesh object remains linked even with its physics set to none, its custom physics model might still interfere with the physics engine, because, like I said, the physics engine treats the linked objects as one unified entity, and the physics that were uploaded, the physics model that was uploaded and baked into that object can do that. So that's why I say build the entire outside, not parts, not 5 or 6 prems that overlap this. You want one root prem or goes all around it, and that will create the root prem physics influence and prioritized over the internal prem, mesh prem, or whatever. And so you can set that to none, and even with the physics model of it, it will not override the root prem physics influence. And really, that's about all I can say about it. Just don't assume that changing a rock to stone, physics shape of prem or convex hull, and then setting it to stone or rubber or plastic is always going to work out as you expected. Your balls, the golf balls will fall through it. Your kid, your baby could crawl through it. Because really the physics shape that's baked in might not match the exact dimensions and every part of the object, or the house wall, or the bench, or the table. You're not going to run into too many things that are perfect to the shape. The physics shape is not perfect to the actual shape, and baked in when that's uploaded, that model. So this is how I would get away with it. And like I said, you don't have to do it for every object, but you should do it for some. Anyway, take care, and I'll see you at another time.